Good morning, dear students. I hope you had a great time during this short break which we had. Anyways, let us start. And now onwards, I'll be little. I won't be writing down the steps. I would be directly dealing with the steps now. I hope you have practice at your end, and now you are comfortable to solve simple DC circuit problem, which we have already dealt with, right? Uh, Up till now, we have seen only one source in a circuit. Then we tried to solve this one in last lecture, and we arrived at these two equations, right? And uh, if you solve these two equations, you'll end up getting the answer, at which you can verify with the simulation. So you will get I1. I'll write down here. Please note down this value, and whatever we have got is this. So I2 will be 1.667 ampere, and I1 plus I2 is equal to 3.334 ampere, right? So I hope you have understood how to apply KCL for this given circuit and trace the closed path clockwise, anti-clockwise, and then you have got two equations because there are two unknown. Then you solve it and you arrive at this answer, right? These are all important. So you can always have this luxury to, in our time we missed this opportunity. In our time we need to verify our answer with using different theorems. There were shortcuts, which we'll discuss later on. But we had a tough time dealing with DC circuit. We never had this opportunity. This is a luxury for you. So make use of this. It is very simple to get this interactive simulation on your PowerPoint presentation. Just go for a developer section, and there you can find out add-in. And you can always add this in your PowerPoint presentation. You can play with it when you are board. You can play with a different circuit. You can add batteries of any magnitude, add resistances in series, and try to play with the simulation. You'll get to know how the DC circuit is actually giving out current, right? So let's go for different one. Yes, good morning, Digvijay. Thank you. Let us begin. So I hope you are having a pen and a notebook in front of you so that you can solve. It is good to have a calculator. You can use the calculator, the scientific calculator, right? Have it in front of you so that you can draw this circuit with me. And I am now we have got three sources. Up till now we have solved with one source, two source, and now we have got three sources. Let us try to understand this problem. Let me draw the circuit diagram first. And this is a 10 volt, 10 volt, and 10 volt, right? Now we want to solve this, and I'm not going to write down the steps henceforth because it consumes times, and we know now, and right. we want to use branch analysis. And what do you mean by branch analysis? You must have observed that we need to use KCL and KVL both, right? So, and that is why this method will not fail, you know. In fact, none of the method fails, but then this is a foolproof method because we've been using KCL and KVL, right? So uh, it is a very foolproof method rather. I'll be writing, I won't be writing down the steps. I'll be, the first step, as we know that we need to mark this node or junction, we call it. And let us assume this is the current flowing through this, that is I1, that is, what do I say? There are 3 batteries now, and we used to name this R1, R2, and R3, right? So similarly, I can name this one is V1. I'm writing it down over here, V2, and this one is V3, right? So V1 is supplying current I1. So is V2 is also supplying current. So how much would be this? We know now. We are applying KCL at B junction. That will be I1 plus I2, right? Now, what do we do next? I mean, I don't have a space to label it, but then, okay, anyway, after assuming the current, unknown current through all the branches, what can I do? I can just mark the positive and negative, right? The sign convention which we use, right? So current is flowing downward like this, right? So this end will be positive and this end will be negative. Similarly for this, what will be the case? Now look at this, you know, this, though this end is positive, this end is negative. So I've told you in a past lecture that student uh, do commit mistake at this point. They when what they consider that as this uh, end is positive, this has to be positive. Don't do that, because this sign convention is based on the direction of current, and keep that in mind. So this will be positive and this will be negative, right? Same is for this one, right? This one is positive and this one is negative, right? Let me use different colors so that you can identify the junctions, the path which we want to trace. A, this one is A. B, I hope you are able to see this. This one is C. Sorry for that. This one is D. This one is E, and this one is F, right? So good. Now what do? We need to write down. Whenever you solve branch analysis, it is better to write down the steps. Steps 1, that assume the unknown direction of a current as shown in the diagram. Then mark the polarity and label it across the junction. Mark the polarity of across the resistance based on the direction of current. Then label it, and then apply KVL. Apply KVL for any 2 loop, right? So I'll be taking a loop here. This one is A, B, E, F, A. Try to solve this one. This one, I'm considering this loop, right? I'm going. It is better to mention the direction in which you are tracing the path. This makes difference, no? So I'm going clockwise. So what do I get? So try to solve this one. A, B, E, F, A, right? So from where A to B and from B to A, what do I see is, I'm writing down the equation. Please try to write down plus 2I2, right? From B to E, right? From B to E. I'm going from a lower potential to higher potential. There is a rise in potential. So there is a rise in potential drop. This is called a potential drop, right? Then this is minus 10, right? Then this one is from E to F, and from F to A minus, plus 10. See, plus 10
minus 2i.
minus 2i.
I1.
1, which is equal to 0, right? So we have got one equation, right? Then I'll go for another loop, that is B, C, D, E, B, again going clockwise, right? I'm trying to trace this path, right? I think, I don't know whether this, ma'am, please ask them to,
Yes, yes, sir.
there is some disturbance at your end. So what do I do now? From B to C, I don't see any element. Then I'm going from C to D. What do I see is minus 2, right? I1 plus I2 minus 10, right? Please try to write down and trace the circuit with me so that you'll get these things. This is plus 10, then
Minus 2i.
minus 2I2, which is equal to 0, and we have got the second equation. Ultimately, we need to substitute and solve this, and I'll just directly write down the steps after solving this 1 and 2. I'll just put down the steps over here. So this will be minus 2I1 plus 2I2, it comes out to be 0, right? When you solve this one, you will get this, right? You will get this one. And second, after solving second, you will get plus 4I2 is equal to 0. Please try to see whether we have done this is all right or not. Please
That
try.
is minus 2i1, sir.
This one is na?
Huh.
This one is minus 2I1.
Huh.
And this
Below
one?
also.
Below also, this one?
Huh.
I've taken out minus 2 sign.
Okay, minus 2
Okay.
sign. Okay,
Okay.
Sorry, sir.
Doesn't matter.
Doesn't matter.
Let them solve this one. Okay. So dear student, we have got this one, right? Now you will be surprised to see that this gets cancelled out. This will be 6I2, and we are getting 0. Your I2 is 0. I2 comes out 0. Great. We have to be 100%. Why don't you verify this with the simulation? But I don't need to verify with the simulation because I know how the circuit behaves now. We'll go into it, but right now what I see is surprised to get I2 is equal to 0. Now, if I put this I2 over here, I end up getting in any one of the equation, if I put I2, I'll get I1 also 0. So do we need to solve this problem to know that the current would be 0? Not exactly, because if you look at the source voltage, 10 volt, 10 volt, and each of them is having same resistances. See, each of them is having same resistances. So So what will happen is they are not able to supply the current because they are of equal potential, right? And we know that current always flow from higher potential to lower potential. But this B point is at equipotential. Are you getting my point? See, this B junction is at equipotential. Whatever the potential at this point is same. You can imagine the circuit like this, no? If I draw this one, same circuit, 10 volt, 10 volt, and 10 volt, right? Let us assume this internal resistance is 0, this internal resistance is 0, this internal resistance is 0. And if I connect it, what will happen? It is as good as 3 sources are in parallel, right? And how they would supply the current? They cannot. And that is why we have got this I2 and I1 0. Now, if I have one more resistance like this in C parallel with it, all these sources are going to supply current through these resistances, right? I hope you are getting this point, because when we started with, we blindly try to solve using branch analysis, and after solving we got I1 and I2 0. This need to be known before we solve it, right? Because this is important step. So there will be you won't be getting this kind of a problem in your examination, but this is just for fundamental reason. But so it is very important to know the potential, right? It is very important to know the potential at a given junction, and this will help you to understand few concept, few theorems which we are going to learn, right? So this was a tricky one, but then you may expect this problem for homework or a unit test. Uh, be ready for such problems, because these problems are intuitive. I mean, they'll make you to understand the concept, right? And this is a simple problem, but it tells you about what do you mean by this circuit, right? What do you mean by this circuit? What do you mean by internal resistance? Now, if I change one of the resistance, say I make this, say 5 ohm resistance, then the things would be different. You can try, right? So changing the circuit parameters changes the current flowing through it, right? So you can always try solving such a circuit, which are comparatively simple, right? Then we'll go for another one. Though we have tried to solve with the 3 sources, but we end up getting something different, and now we'll try to solve another one, second problem. I hope this color is comfortable to you. I'll go for black, and then let me draw the bigger diagram so that I won't be messing up with the junctions. What I have is a simple circuit again, drawn in different fashion. It is same as the previous one, but only thing is, see, I'm not trying to confuse you all. I mean, I'm trying to make you understand that there are some circuits wherein when you try to solve, you'll end up getting unexpected answers, right? So we have to be 100% sure before we solve any problem, right? So this problem is a kind of a will give you a little bit of surprise. Let us solve this one. I'm fond of 2 ohm resistance, so I'll keep that. I like 2 ohm resistance because saves our calculation time. I won't mind putting this 13 volt or 11 volt or something which is hard to sometimes if things becomes complicated, I want to keep it simple because we want to understand the concept, right? How do I solve this one? So let me choose a current which, okay. So let us call this one is I1. You can call it anything you like. This one is I2. How much would be this one then? This will be I1 plus I2, right? Then draw this and try to write down the equation. I'll be writing down with you. I'm not able to see you all, but then I'm very much hopeful that you are very good students, right? You want to do something, you want to achieve something, right? Be honest to yourself. You don't need to prove to me. Try to solve this. I try to label it because this is how I'm comfortable with. So when I'm on a diagram, I just do not want to okay. Now what else is pending is this one, right? Polarity. I'll mark it. This one is plus, this one is minus, this one is plus, and this one is minus, plus and minus, right? So let me trace the path, that is A, B, E, F, A, and apply KVL, right? So what you'll get, minus 2 I1, easy, plus from B to E, plus 2 I2, minus 10, plus 15, that is from F to A, is equal to 0. So if you solve this one, you will end up getting I1 minus 2I2 is equal to 5, right? This is one of the equation which we wanted to get. Then we are applying KVL, right? I'm going clockwise. Then next is you can always go for the outer loop. You can always go for outer loop. Now I'll trace this one, right? So this will be what? B, C, D, E, B. So what will be that? Minus 2.
Minus 2 I1 plus I2 minus 20.
Minus 20, yes. Then plus
10 minus 2 I2.
Minus 2I2 is equal to 0. Good. So if I solve this one, you need to solve it to get this one, right?
2 I1 plus 4 I2 is equal to
Minus 10, right? Okay.
Yes, sir.
Now, let us, when you solve this 2I1 minus 2I2 is equal to 5. 2I1 plus 4I2 is equal to minus 10, right? Instead of that, I can, okay, so if I multiply this by negative, I'll be getting this one positive, right? I hope you are comfortable with solving simultaneous equation. So this will be minus 6I2, which is equal to 15. And what we have got, I2 is equal to minus 2.5 ampere. Great. So
Yes.
we get to know something. No, it's negative. It is negative. The current is negative means what? This I2, which we have assumed that it is taking current, supplying current. Rather, it takes current, right? Very important. It takes current. So here we need to write down that assumed direction of I2 current is wrong, right? It is not flowing from E to B, rather it is flowing from B to E. It is flowing downward, right? But here we don't make any correction, right? While we put this I2 in a given equation, right? Any one of the equation to get I1, right? So if you solve, you will get I1 is equal to what? What you are getting?
I1 is equal to 5 ampere.
This is what you are getting. What you are getting I1. Let us put this value in this equation, one of the equation. This will be minus 5, right? Minus 2.5 into 2, that is minus 5. Sorry, I'm trying to find out for I1, right? So this 2I1 minus 2 into bracket minus 2.5 is equal to 5. So 2I1 plus what? This will be plus 5, right? This will be plus 5 is equal to 5 and I1 comes out 0. You can solve this, right? Take your time. So surprise again. So great. I2 comes up zeros. That means the 15-volt battery is not taking any current, right? It is idle. It is not doing anything. It is rather not supplying current, taking current, the current as if it is of no use in a circuit, right? Because and because of that, sometimes and you can always do this with your animation. You can verify this answer if you wish. But the point which I want to make here is, when you look at the circuit, you won't get at first instance sometimes that what is happening inside the circuit. So we need to solve a circuit, and that is why we are using these methods, right? So sometimes you will be dealing with the tricky problems that time. Uh, so this is a redundant branch, as if this is in a circuit, but it is not taking any current. It is a redundant branch. So what do I do? Can I remove this branch? No, I cannot remove that because it makes certain potential at this point, right? So if I remove it, there'll be lack of potential which is required. Okay. So I hope you are getting this point. Let us go for the next problem. Please try to solve this one, I1 and I2. Please do write that this is a negative current. So actually the current direction is downward rather than upward. Let us go for the another one. So now we know how to solve a circuit which is having 3 voltage sources, right? We can always try to solve let's go for this one. Next one is Third problem. This is for your two ohm. This is 10 volt. This one is 10 volt. This is 20 volt. So I try to solve this one, and I'll be solving with this. You can let me label it as I always do. I hope you are all solving this one with me.
So what is the value of this middle resistance?
Which way? This one, okay. 2 ohm. As I said, I'm very comfortable with 2 ohm. I'm not happy with this color actually. This one is I2. This one is I1. And this will be I1 plus I2. So now I won't be writing down which path I'm tracing. I'll just, you try to figure it out. I'm doing it for which path. And by now you must have got what I'm comfortable with. So let me write down first the equation. I'm just tracing the path. You try to figure out which path I'm trying to trace. Minus 2I1 plus 2I2. Minus 10 plus 10 is equal to 0. If I solve this one, minus I1 plus 2I2, I'll be getting equation 1. So which is this path? You must have guessed, right? This one is the path I'm tracing. Now I'm left with this one or this output path. I'll go with this, right? I'm going to write the equation directly. This will be minus 2I1 minus 2I2. This is the second path I'm trying to trace. 20 plus 10 minus minus 20 plus 10 minus 2I2 is equal to 0. And when I this is what I'm getting. So how will you solve this one now? Minus 2I1 plus 2I2 is equal to 0. Is equal to 10. I can multiply this by negative sign. What do I do? I can multiply this, or I'll multiply this one so that, and this will be minus. Right, so this gets cancelled. This one is 6i2 is equal to minus 10. So by 6, it comes out 1.667 ampere.
minus 1.667.
Okay, yeah, minus 1.667, fine. So when you put this in one of the equation, what you'll get? What will be the I1? How much is that, ma'am? That will be same, right? Because
Both are same, but direction is reverse. Both are same.
So this also comes out negative, right?
That is also minus.
This is also negative. Yes. Great. So now what can you figure out from this? Now I1 and I2 which we have chosen coming out negative means what? In short, 10 volt, both the 10 volt batteries are not supplying current, rather 20 volt is supplying current to the 10 volt. And we know why, because the current always flow from higher potential to lower potential. So whatever the assumption we made, that the current is flowing in anti-clockwise direction, rather it flows in, clockwise direction, rather it flows in anti-clockwise direction, right? So assumed direction of I1 and I2 are incorrect. So try to solve this one. I hope you are getting this, right? We'll solve last one. If you have not got, try to solve this one. I'll write down, say rather it, the current actually flow in this direction, right? So this 20 volt is supplying current. So current all are flowing in this direction, right? In this direction. And which is very obvious because current always flow from higher potential to lower potential. So be comfortable with such problem, try to solve on your own. And I'm very sure that you'll be able to solve this. It's not difficult at all. We'll solve this one, fourth one, the last one. Now we are having a problem which will test some of the concept which we have learned. And in fact, such problems are very easy to solve. You know, these are 2-step, 3-step problems. So don't go by the circuits. Sometimes circuit looks difficult. Yeah, here is 4 ohm, right? Please make 10, right? So how do I solve this one? In this circuit, I am having a current source, so I cannot use the KVL for, let us write down the nodes, right? A, B, C, D, E, F. See, I cannot use KVL for this junction. Neither I can use it for this outer junction because it involves this branch where is the current is flowing, right? Now, how do I solve this? I'm left with only this loop. If I have to apply, let me erase all this. These are So I'm left with this one only, this one, right? Now what do I do? As we have discussed, in fact, we have solved one problem on this. This is a 4 ampere current coming towards junction B, right? This 4 ampere coming towards junction. I won't mark the unit there, so sorry for that. Just put 4 ohm there because we want to write down KCL at this, right? So the 4 ampere is coming towards the junction B, and this is the only branch which is not having any voltage source. In fact, at this branch having, say for example, it is having 5 volt over here. In that case also, this branch would have taken current, because the 10 volt is always more than the 5 volt, so current obviously will follow through that uh, resistance, right? But anyway, so for this problem, let us not make things complicated. Let us apply KCL at this junction. So 4 ampere is coming towards the junction. Let us assume this current is I1 supplied by the battery 10 volt, which will flow towards the junction B. So what will be this? I'm applying KCL at this junction, right? So this will be 4 plus I1, right? And now let us try to verify whether the KCL gets applied. See, this 4 plus I1 will flow through this. I hope you have understood. I have applied KCL at this junction, right? So this will be 4 plus I1, right? So this will be 4 plus I1. I'm trying to apply KCL at this junction now. So 4 plus I1, just to verify, I'm just cross-checking it. 4 plus I1 arrives at junction E. Out of that, I1 flows away from it, right? Flowing away from it. So how much is left is 4. So we are back to our source, right? So 4 ampere is going, 4 ampere is coming out, right? So this is how in every circuit you can apply a KCL. If you are having a doubt whether my KCL is, whether I made a mistake or not, you can always cross check with other junction, right? So whatever is going out should come in, right? That is how the circuit gets completed. I hope you are getting what I'm trying to explain. So here I'll be applying KCL, sorry, I messed up. I cannot apply to this, right, AB, because it includes, I have to apply it for P, C, D, E, B, right? So, oh, I forgot to mention the polarities here. I hope you are trying to solve this with me. Okay. So this will be so this, what is this? From B to C, nothing is there. This is 4 minus 4 into bracket 4 plus I1, right? Is it okay?
Plus 10.
Plus 10
Minus 2I1.
minus 2I1 is equal to 0, right? Is equal to 0. Okay. I am getting 16. Let me solve this one. Minus 4I1 plus 10 minus 2I1 is equal to 0. When I solve this one, I'll get I1 is equal to minus 1 ampere.
Minus 1.
Is this right, ma'am? Sorry.
Yes, sir. Yes, sir.
Okay, thank you. at -1 ampere. So if so that's it. I mean, the current through 4 ohm is -1 only, right? And how much is the current through 4 ohm resistance? How much will be the current? And -1, see, I mean, it is I1 is -1 ampere. That means what we have assumed, it is coming out. No, it is.
It is outgoing current.
No, I mean, it is -1. So whatever the assumed direction of current was wrong, right? Rather, it takes current. Is it not? It is taking current now.
Yes, yes.
It is taking current. So sometimes things are different than what we can have. In fact, I told you before we start solving this problem that this is going to supply current, but then I got it wrong, right? It is taking current. So circuit behaves sometimes in a different fashion, uh, and you assume something different. So it is always better to solve the circuit with whatever the tools available with you, and you have uh, in fact the simulation doesn't include this current source, so you cannot solve this problem in simulation, but you can see that it is a 1 or 2 step problem. Now if I have to find out current through 4 ohm, how much will be the current? That is 4 minus 1, right? And it is plus I1, right? So -1. So how much will be the current? The 3 ampere flows through it, right? So the 3 ampere current flow through the 4 ohm resistance and 1 ampere flow through this, right? So total comes out 4 ampere. 1 ampere flow in this branch and 3 ampere remaining flow through this branch. So we'll solve. Uh, I think I don't know whether you are comfortable with this, all the branch analysis circuit which we have solved. We have started with a single source, then we started with 2 source, then we also had a current source included in it. And now we are dealing with 3 sources, and we have done with branch analysis. I hope this, whatever the numericals we have solved, you are all comfortable with it. And I'll suggest try to solve various numericals which are given in the book. In next lecture, we'll take 3 loop problem, though from our syllabus point of view, don't worry, but we want to know whether we can apply it for 3 loop and will it be easy. And generally 3 loop problems are difficult to solve. So we'll try to solve 3 loop problem in the next lecture. Try to read the Cramer's rule if you are solving 3 simultaneous equation. So we'll be dealing with Cramer's rule. So go through it. I hope you all know how to solve a simultaneous equation. But then there will be 3 loop, 3 unknown, 3 equation. And so if you are comfortable with Cramer's rule, you'll get to know how to solve the 3 loop problem, right? Thank you for joining, dear students. Have a nice day. Goodbye. Sagar sir, shall I leave? Hello, Sagar sir. Sagar sir.
Yes, sir, you can leave.
Thank
Please assign as
please guide me for that. Students, you can join after 5-minute break. Sir will resume the lecture after 5 minutes, right? Meanwhile, you can have a break. Madam, can you guide me to Assign, sir, is
On Sagar Balgude sir, there is an arrow in front of him. More option is there
okay, okay,
on Sagar Balgude sir.
okay.
So click on your three dot right hand
Make
side
him.
corner.
Yes, yes, I got it.
Yeah. Okay.
Is that okay, sir?
Yes, yes. Now
Thank you
host
for
it.
your guidance, sir. Have a nice day, sir. Thank you.
Okay. Okay.